All right, so 6.5 is graphs of tangent and cotangent functions. So I'm going to set up a parent function graph for this one. It's still going to go out to 2 pi in both directions, so negative 2 pi to 2 pi. And tangent and cotangent functions don't have amplitude, so you don't need anything on the y-axis for these ones. So I'm going to do tangent first. Now, where is the tangent function undefined on the unit circle? Now, what radian values? Pi over 2, and where else? 3 pi over 2 and 3 pi over 2, and if I continued to go around every increment of pi over 2, it would be undefined. Okay, so that means that our graph will not be able to cross that, and so we have vertical asymptotes at increments of pi over 2. So those are dotted lines, not solid. And these are lines that the graph cannot cross. So if you were to be going out to 4 pi, okay, we would have more asymptote lines getting drawn. Then the tangent graph, what it does is it actually comes up by that asymptote, and it comes through that point 0 and kind of like almost not changes direction, but kind of like changes the concavity of it going up. And it looks like that all the way across. So same thing here. And like that. When you're drawing these graphs, when I'm grading them, what I'm going to be looking for is that you have the asymptotes in the right place, okay, with dotted lines, and that your tangent graphs have this shape here, but specifically that they're going through these points of increments of pi, okay? If I kept going, then my graph would continue going through 2 pi and so on and so forth. But when I'm asking you to draw the parent function, I'm looking for this region here is what I want to see on your test. And so if you ever forget where those asymptotes are, just look at where the graph is undefined on the unit circle, or like where tangent's undefined on the unit circle, and then you'll know on the graph. Cotangent is very similar in shape. We're going to have the same increments out to 2 pi in both directions. And something I noticed on your quiz is that several of you did not put increments on your parent function graph, and if you lost points, that probably is a good reason why you lost them, because you didn't have that on there. So make sure when you do them for the test that you put those markings on here. Now, where is cotangent undefined? Yep. pi and 2 pi. Okay, so where tangent is 0, cotangent would be undefined. Okay, so that means at every increment of pi and 0, okay, we have a vertical asymptote. So that means that I'm going to have asymptotes here on the y-axis. So I'm just going to kind of draw the line, the dotted line there, kind of beside it. Maybe extend it a little bit so we can see it. Then it's at pi and at 2 pi. Then at negative pi and at negative 2 pi. So when I do the graph of cotangent, okay, this one is a little different in shape. So with tangent, we started at the bottom and we came up. Cotangent's opposite. We start at the top and we come down.
Do we have to worry while she's doing something?
Huh?
Do we have to worry while she's doing something?
We're doing stuff.
Okay.
I need her for at least 10 more minutes.
Okay, whatever y'all do.
Okay. Then over here, come down. Oh, I missed it. 33 pi over 2, and goes down like that. So this one is just flipped from tangent, basically. So a couple characteristics that you need to know about the tangent function. Okay, you don't have to do anything special with cotangent and then cosecant and secant. For cotangent, cosecant, and secant, you'll just have to know their parent functions. But the characteristics of y equals a tangent of bx. Okay, so just like we had for cosine and sine. The period and vertical asymptotes. Oh, I should write that out probably. And vertical asymptotes I will often abbreviate as VA just for short. Of the graph of y equals a tangent of bx, where a and b are non-zero real numbers, are, so the formulas that you need for these, period is pi over the absolute value of b, and vertical asymptotes are at odd multiples of pi over 2 times the absolute value of b. Now, the reason they're putting absolute value of b is sometimes that b value is going to have a negative sign on it, which just is causing something else to happen. But for what we're doing, it should just be that.
Do you still have your Uno?
All wild or the emoji one?
Oh, wild. Can we use it? Thank you.
Mm-hmm. All right, so I'm just going to do like 2 examples of this, and then I'm going to give you 3 for homework, okay? These instructions are completely modified from what the book says. They want you to graph them. We are not graphing these, okay? The modified instructions for this, you're going to state the period and vertical asymptotes. Okay, and that will be all that I ask you to do on the test for tangent problems. Okay, the only ones you have to actually be able to physically graph a non-parent function of is sine and cosine. So if we have the problem, now this is problem 14 out of the book, but again, the instructions are different, so you can kind of just disregard it. Y equals the tangent of 1/2 x. So the period of this is pi over the absolute value of b, but this is a positive number. So it's going to be pi divided by 1/2. So I'm dividing by a fraction, so keep, change, flip. The period is 2 pi. Then vertical asymptotes. We do pi divided by 2 times b, so this is going to be pi over 2 times 1/2. So 2's cancel down here on the bottom, so I'm left with pi over 1, which is just pi. And that is all you have to do on these tangent problems. Then 22.
Wait, we don't have to graph.
No, I just said all you have to do is do this. Disregard the instructions that are in the book. Y equals 3 tangent of 1/3 x. So thanks. The period is pi over, b is 1/3 on this one, so pi over 1/3. So keep, change, flip, that gives us 3 pi. Then the vertical asymptote for this is pi over 2 times b, so 2 times 1/3. So that's pi over 2/3. And we keep, change, flip, that's going to give us 3 pi over 2. All right, I'm going to write out the 3 problems that you need to do for homework. I'll tell you what number they are in the book, but again, I wouldn't even open your book, okay? Because all I want you to do is state the period and vertical asymptotes. And if you open your book, you're going to be tempted to do the instructions that are in the book, okay? Disregard those instructions. So your homework is number 13, 15, and 21. Number 13 is y equals the tangent of 4x. 15 is y equals 2 tangent of x. And 21 is y equals -2 tangent of 1/4 x. Now, something I didn't mention is the number that's in front of tangent in this one, what would have been our amplitude value for cosine and sine, is irrelevant, okay? There is no amplitude to a tangent function, okay? So the only number that we care about is the number that is inside of here, okay? Disregard the other ones.